characteristics. And so in using this process, I've actually been able to make some eggs. These ones hold about, I think it holds about 5 gallons or something. It was made as a water device. And this shows you a little bit more how you can make sections through these cones. These are various sections taken through the cone, and from these you get a number of different egg shapes. This one, for instance, would be taken. It's difficult to do this without relation to the cone. I'll try and put that back here. No, I think I'm going to take it out. It depends how pointed the egg is, depends on how steeply you make the cut through the cone. And it doesn't matter where you make the cut on the thing, you can always define it from a mathematical point of view. These are all different egg shapes. And these are the data which correspond to it, so that it does show you that they can be very precisely defined. It's a different one. I'm afraid it got slightly wonky at the end. And there's another one which is more leaf-shaped. So all these can be drawn out of Walter Schauberger's maths, which again is this very simple form of maths based on the equation 1 over n times n equals 1. And I think probably there's just one more point that I would like to make, and to show how this relates to the orbits of the planets. This is the same sort of section that we had before, where there are various sections taken through the cone. Now these ones correspond to the planets themselves. I did this one deliberately to find them. And so this orbit here is the orbit of Mercury. Now we say egg-shaped orbits, and actually it's the inside one is egg-shaped. The outside one is the corresponding shape of an ellipse, using the same eccentricity, as it's called. There's one focus and there's the other focus if this were ellipse. If this is an egg, there's only one focus, which is here, and that concerns the inner line. Now if you were trying to find the planet, in this particular instance, this being Mercury, there's a variation of something like 4.8 million kilometers between here and here. So if you were trying to land a spaceship on Mercury and you were using Euclidean geometry, you could be quite a long way away. And I do believe that when they tried to land one of the landings on the moon wasn't where it was, and they had to use up quite a lot of fuel in order to actually get there. And the thing may have been the result of this discrepancy, that the moon they thought was here, but it actually was here because it was following an egg-shaped orbit rather than an elliptical orbit. And these planets then they also interestingly, they also follow a line, a hyperbola, where you have the orbital velocity times the distance from the Sun, and those create a constant, and so you can plot very easily where all the planets lie on this hyperbola. So the mathematics of Walter Schauberger and his father's processes, which are always these reciprocal things which end up in the unity, or they show how that energy can be created, or the paths that energy wants to move in, are very much integrated. And I think they really need to be brought into focus for a new direction in technology, a new direction in environmental treatment, a new direction in water resources management, forestry. In fact, a new direction in almost any avenue of human endeavor that you can think of, because we seem to be doing it wrong. If we were doing it right, we wouldn't have the problems we have today. And it seems to me that Viktor Schauberger and Walter Schauberger have some way, they're not the whole solution, but they have got part of the solution at least, which allow us to understand how we can change the environment, how we can restore the climate to a state of balance, how we can do so many things to improve agriculture so that we can have far more people alive on this planet, but fed well, housed well, all those things. If some of the information, or perhaps all of the information which Viktor Schauberger has to offer, can finally be integrated into a different society. Now, Viktor had one thing to say, and I quote him. Firstly, well, two things. First is, if you want to know what the right thing to do is, do exactly the opposite. You must comprehend and copy nature. And then one quotation from him, which I think is very telling. He says, "They call me deranged. The hope is that they are right. For it matters, it's of little import if yet one more fool should wander this earth. But if I am right and science is wrong, then may the Lord God have mercy on mankind." And he wrote that in 1930, after seeing what would inevitably happen if all the various technical processes we set in motion continued unchanged. And that is exactly where we have got today. In 1930, he forecast all the environmental problems we are having today, and he said exactly why. So I think that's where I shall bring this to an end.